Hey, hi, welcome to the class. So, this session is about problem solving on GATE 2020 questions in ECE, and I'm going to deal with the questions on communication systems because that is my expertise. So, let us discuss the questions. Right. So, this is one of the questions, and it's a very interesting and a little tricky question. So, yeah, this question can be solved in multiple ways. Students who have listened to my class can solve this in multiple ways. So let me show you different ways of solving this. So the very basic way of solving this is they're talking about variance of y. So which means they're asking us to find sigma y square. This is what is the question. Okay. So sigma y square can be understood as, we know the relation expectation of y square can be written as sigma y square plus expectation of y whole square, right? So y is given, like this: integration from minus infinity to plus infinity w of t into phi of t dt. So let us find what is expectation of y. Expectation of y is equal to expectation of integration from minus infinity to plus infinity w of t into phi of t dt. So expectation, we can take it inside. Here phi of t is a deterministic signal. So expectation can be taken inside, and we can apply it as expectation of w of t into phi of t. Phi of t can be put outside because phi of t is a deterministic signal. Expectation should be applied only for random signals. So deterministic signals can be treated like constants, and we can put it outside the expectation. So this value is equal to, so expectation of w of t. So white Gaussian noise process. So generally white noise has zero mean. They did not say it here, but we know it. So additive white Gaussian noise has zero mean. So hence it is integration from minus infinity to plus infinity 0 times phi of t dt, which is equal to 0. Right. Since mean is 0, expectation of y square, finding expectation of y square is as good as finding sigma y square in this problem because expectation of y is 0. Right. So fine. So let us find what is expectation of y square. Expectation of y square is equal to expectation of y into y, which is equal to expectation of integration from minus infinity to plus infinity w of t into phi of t dt into integration from minus infinity to plus infinity w of t dash into phi of t dash into dt dash. Since two integrations are there, variable of integration should not be same, so that's why I'm taking it differently, right? So this can be further written as integration from minus infinity to plus infinity and integration from minus infinity to plus infinity. So this expectation can be taken inside and can be applied on w of t and w of t dash, because w of t and w of t dash are the random parts, and phi of t and phi of t dash, they are deterministic parts, dt dash and dt, right? Next, so what is given about the random process? Regarding random process, they have given the power spectral density, and if you can find the inverse Fourier transform of power spectral density, we get autocorrelation function. Rw of tau is the autocorrelation function corresponding to W of the random process, which is equal to inverse Fourier transform of power spectral density. What is the inverse Fourier transform of constant signal 3? It is 3 times del of tau, or the Fourier transform of 3 times del of tau is 3. So we just now found what is the autocorrelation function of noise random process, right? One more thing given about phi of t is it is equal to 1 from 5 to 7, right? Let us use this basic here. So we just now found out what is r of rw of tau. Let us keep it here. which is equal to 3 times del of tau. And we were talking about expectation of y square. Expectation of y square is equal to, where did we end up previously? Previously we ended up at right, so we ended up here. So phi of t, if you substitute here, it is equal to 1 from 5 to 7. T runs from 5 to 7, and phi of t dash also is equal to 1. We can substitute 1 here for a t dash running from 5 to 7. So both limits will run from 5 to 7 if you substitute phi of t equation here. So it will be equal to this. We can write it as one second. Right. So okay. So expectation of y square is equal to, earlier we were writing, if you substitute the equation of phi of t and phi of t dash, so the limits will change from, instead of minus infinity to plus infinity, limits will change from 5 to 7. It is expectation of w of t into w of t dash dt dash, and which can be written as integration, double integration from 5 to 7. So we can write this as this is looking like autocorrelation function of w of t, which can be written as rw of t minus t dash, or t dash minus t also you can write, because autocorrelation function is a even function, right? And we know what is rw of tau. What is rw of tau? It is, just now we have seen previously, power spectral density is given as 3, and the inverse Fourier transform of power spectral density will give you autocorrelation function, and we found the autocorrelation function as 3 times del of tau. It is 3 times del of tau. Rw of tau is 3 times del of tau, but Rw of t minus t dash is 3 times del of t minus t dash. Okay, so earlier we found that Rw of tau is equal to 3 times del of tau. But what we want here is Rw of t minus t dash. Replace tau with t minus t dash. On the right hand side also t minus t dash. That is what I'm substituting here. dt dash. Now if you observe, integration of impulse may result in a constant or 0 also. So here if you observe, t is the variable, so the impulse is located at t equal to t dash, and if you observe, t dash runs from 5 to 7, t dash runs from 5 to 7, so the location of the impulse is between, the impulse of location is at t dash, because t equal to t dash, when t equal to t dash, the inside part becomes 0. The location of the impulse is at t equal to t dash, and the t dash runs from 5 to 7, and we are integrating from 5 to 7 only, so that's why integration of the impulse will be 1. So 3 times integration of this part, it will become 1, and what is left is dt dash. The reason for integration is, if the impulse is within the limits of integration, then integration will become 1 for unit impulse. If the integration of impulse is not within the limits, for example, let's say there is an impulse at 3 units, del of t minus 3. And if I say some 2 to 4 del of t minus 3 dt, this is 1, because the location of the impulse is at t equal to 3 and it is within the limits. But similarly, if I talk about 4 to 7 del of t minus 3, and trying to integrate from 4 to 7, if the impulse is not located in that region, so area will be 0. So we just need to verify whether the location of the impulse is within the limits or not. Here if you observe, t is running from 5 to 7, and t dash is also running from 5 to 7, and hence location of the impulse is between 5 to 7, and integration of limits also are from 5 to 7, and hence that's why integration of this impulse is 1. Next, integration of this is 3 times integration of t dash is integration 1 dt dash is t dash, limits from 5 to 7. Now if you substitute the limits, it becomes 6. Yes, that's what is the answer. That is the answer. So this is one easiest way to do the problem. So there are other ways of doing it also. So what are the other ways? The other ways will be little, yeah, the other ways also we can do it easily. So let me explore other ways also. Right, so the other way is, so you can think of it as, you are passing W of t through a system h of t. So what we have here is let's say y of t is equal to integration of W of tau into h of t minus tau d tau, limits from minus infinity to plus infinity. You can understand it this way. And if you put y of 0 t equal to 0, limits from minus infinity to plus infinity, W of tau into h of minus tau d tau. And let me replace W of tau with phi of tau d tau, where phi of tau is nothing but h of minus tau. Okay, so y of 0, let me say y of 0 as just y. So the whatever they have asked us is this function. Okay, now phi of tau is defined as it is 1 for 5 less than tau less than 7. It is equal to 0 elsewhere. Now if you talk about h of minus tau, h of minus tau is same as phi of tau, right? So h of tau is same as phi of tau, sorry, h of minus tau is same as phi of tau. So what about h of tau? H of tau is equal to phi of minus tau, phi of minus tau, phi of minus tau is equal to, it is equal to 1 for minus 5 minus 7 less than tau less than minus 5. It is between minus 5 to 7. It is equal to 0 elsewhere, which means h of tau, if you plot it, it is going to be a signal like this, from minus 7 to minus 5 with a height of 1 unit. Now we got h of tau, so we can find h of minus tau also, right? H of minus tau also we know, which is equal to 1 from 5 less than tau less than 7, and it is equal to 0 elsewhere. So this is h of tau. And how about h of minus tau? It is a function from 5 to 7, tau running from 5 to 7. So this is h of tau and this is h of minus tau. So you can imagine whatever function they have given this function as, okay, W of t random process is passed through an LTA system, with impulse response h of t. The output random process with y of t is like this. And in this output random process, at a particular time instant, t equal to 0, what we have a random variable at t equal to 0. Y of 0 is a random variable, and that random variable they have given us. They are not talking about output random process. In that output random process also, they are talking about a particular instant, which means they are talking about a particular random variable inside the random process. They are talking about this case. So we can talk about the general case also, right? So once we get this, so what they have given is, they have given power spectral density SW of f. They have given. From this we can find autocorrelation function. So this they have not given, this they have given, and from this we can find this, right? Once we know the autocorrelation function, so can you tell me what is the autocorrelation function at the output? So Ryy of tau, or Ry of tau, is equal to Rx of tau. We know output autocorrelation function equal to input autocorrelation function. Since the input is W, let me write as Rw of tau convolution with h of tau convolution with h of minus tau. So which is equal to, you can observe here, so Rw of tau we know, which is 3 times del of tau convolution with h of tau convolution with h of minus tau, right? convolution with h of minus tau. So this is equal to 3 times del of tau convolution with h of tau is h of tau only, h of tau convolution with h of minus tau. So what we are interested is what variance of y. Variance of y or mean square value of y both are same because mean is 0. So variance of y, how can we find it from autocorrelation function? So what we need to find is ry of 0. That is sufficient to find expectation of y square, or in this case sigma y square, both are same. So autocorrelation function at tau equal to 0 will give you the mean square value, and in this case mean square value and variance are same. So they are asking us to find the variance, which is as good as finding mean square value, which is as good as finding autocorrelation function at tau equal to 0. Now we can find the autocorrelation function at, we know h of tau and we know h of minus tau. We know how to do convolution. If you do convolution of these two signals, convolution of two rectangles of equal width will be triangle, and lowest limit of the convolution is sum of lower limits. Lower limit here for this signal is minus 7 plus 5 is minus 2. Lower limit of convolution is minus 2. Upper limit of convolution is minus 5 plus 7 is plus 2. We know that the resultant of these two convolution will result in a signal from minus 2 to plus 2. And we also know that convolution of two rectangles of same width will result in a triangle. And what is the height of the triangle? Just multiply these two rectangles, just overlap them, make them, shift one of them to overlap with the other one, and multiply them and then find the area. If you multiply these two rectangles with the height 1, the result will be same rectangle with height 1. So area of that rectangle will be 2 units because the width is 2, height is 1. So or else you can use any other procedure to find the height of this triangle, whichever procedure you are comfortable. So this is the convolution of h of tau convolution with h of minus tau. This is what is the result of. And what we have here is ry of tau is equal to 3 times h of tau convolution with h of minus tau. So what is ry of 0? Ry of 0 is nothing but h of tau convolution with h of minus tau at tau equal to 0. Right? And what is the value at tau equal to 0? It is 2 units. And ry of 0 equal to 3 times 2 units. So ry of 0 is equal to 3 times the value of convolution of h of tau with h of minus tau at tau equal to 0, which is 2 units, which is again 6 units. So I've told you two procedures. There is one more procedure also you can do. You can use one more procedure as well, which is by using the concept of power spectral density. Relation between power spectral density at the output with power spectral density at the input also. You can try that procedure also. So that is the hint I am giving you for another procedure. Right. Coming to the next question. Coming to the next question. Right. Let us talk about the next question. The coin is tossed 2 times independently, and M and N denote the labels corresponding to the outcomes of these tosses. Fair coin, instead of head and tail, they are saying 0 and 1. Okay, and M and N are the outcomes of two coins. They are giving two coins. So what are the values possible for M? When a coin is tossed, either 0 can come or 1 can come. 0 or 1. And for N also, what are the possible values? 0 or 1. Right. So X is defined as minimum of M comma N. Since they are saying it is a fair coin, so probability of 0 is equal to half, and probability of 1 is also equal to half, because they said it is a fair coin. And they are tossing 2 times. One time whatever is the outcome, that they are saying it as M, and another time whatever is the outcome, they are saying it as N. N can take 0 or 1, M also can take 0 or 1. Now if M equal to 0 and N equal to 0, then what happens? It's minimum of 0 comma 0 is 0. So this implies X equal to 0. Similarly, if M equal to 0 and N equal to 1, then X is equal to minimum of 0 comma 1 is 0 again. Similarly, if M equal to 1 and N equal to 0, then X is equal to minimum of 1 comma 0 is again 0. If M equal to 1 and N is also equal to 1, then X is equal to minimum of 1 comma 1 is 1 only. Right. So what they're asking us to find is expectation of X. If you want to find expectation of X, the values of X possible are 0, or 1. The possible values for x are 0 or 1. If you can figure out the probabilities of 0 and 1, then we can find the expectation. If you want to find the expectation, you should know the PDF or probabilities. So let us find it. So probability of x equal to 0 is equal to probability of m equal to 0 comma n equal to 0 plus probability of m equal to 0 comma n equal to 1 plus probability of m equal to 1 comma n equal to 0. And if you observe, m corresponds to outcome of one coin, n corresponds to outcome of another coin, and these two coins are the outcomes of these two coins are independent of each other as given from the data. So now, since they are independent, m equal to 0 is a particular event, n equal to 0 is another event, which are independent of each other. So p of m equal to 0 comma n equal to 0 can be written as p of m equal to 0 into p of n equal to 0 plus p of m equal to 0 into p of n equal to 1 plus p of m equal to 1 into p of n equal to 0. I hope you are understanding why we are writing like this. The reason is because m and n are independent events. So what is p of m equal to 0? The probability of having 0 is half. Whether it is m or n, probability of getting a 0 is half, probability of getting 1 is also half. So this is half and this is half. It is half into half plus half into half plus half into half, which is equal to 3 by 4. And what is the other probability? We can easily guess. Probability of x equal to 1 directly, since it is 3 by 4, this should be 1 by 4. That is one way of guessing it, or else you can do it like this also. When do we get x equal to 1? When m equal to 1 and n is also equal to 1, which is equal to p of m equal to 1 into p of n equal to 1, which is equal to half into half, which is equal to 1 by 4. Right now they are asking us to find expectation of x. Expectation of x is equal to sigma x into xi into p of xi. So which is equal to, which means what are the possible values of x? Take those values, multiply them with the corresponding probabilities and just add it up. So what are the possible values of our x? 0 and 1. The corresponding probabilities are, the probability of 0 is 3 by 4, just multiply with that. Probability of 1 is 1 by 4, multiply with that, just add them up. So which is equal to 0 plus 1 by 4 is 1 by 4 or 0.25. So this is the answer. Easy question. So next question. So p of x equal to 2. They're saying probability of x equal to 2 is alpha, and they're not giving the probability of x equal to minus 2. What is the probability of x equal to minus 2? We know that x can take only two values, plus 2 and minus 2. So sum of the probabilities of plus 2 and minus 2 should be equal to 1. So if probability of 2 is alpha, probability of minus 2 should be in such a manner that total probability should be equal to 1, which means probability of minus 2 is 1 minus alpha. Then only sum of these two probabilities will result in 1, right? So the value of alpha, they're asking us to find the value of alpha for which the entropy is maximum. So this is the most important point. Entropy maximum. Entropy happens to be maximum. Entropy is maximum if all outcomes or all symbols, you can say, all outcomes have equal probability. Equal probability. Here they're talking about only two outcome case. If it is 10 outcome case or 20 outcome case also, same concept. All the outcomes should have same probability. So what should be the probability of x equal to plus 2 and x equal to minus 2? Probability should be equal, which is equal to half. Only when the probabilities are equal, then only the entropy will be maximum, which means they are asking us to find alpha, which is same as half. Because if entropy should be maximum, probability should be equal, which means alpha should be half. Next question. So digital communication system transmits a block of n bits. So they're going to transmit a block of n bits, it seems. N bits. N means it can be 10 bits or 20 bits or 30 bits or whatever. The probability of error in decoding a bit. The probability of error in decoding a bit. Probability of error in decoding. In decoding a bit, a particular bit, is alpha, it seems. which means we can also say that probability of correctly decoding a bit is 1 minus alpha, right? So the error event of each bit is independent of error event of other bit. So whatever error you get here, that is independent of getting an error here. If they are saying errors are independent, each bit error is independent, then definitely the total intersection probability can be written as multiplication of individual probabilities. So this is a very important condition. So whenever we're talking about the total probability, we can just multiply the individual probabilities. Right. So the received block is declared erroneous if at least one of its bits is decoded wrongly. If one of these n bits, total is n bits, total number of bits is n. First bit, second bit, third bit, and so on till n bits. If one of these bits is decoded wrongly, then you are gonna declare the block as erroneous. And when do we declare the block as correct? If all the bits are received correctly. So probability of receiving a block correctly, which means all bits correct, is equal to the probability of receiving this bit correctly is 1 minus alpha. Probability of this bit receiving correctly is 1 minus alpha. Like that, every bit receiving correctly is 1 minus alpha, 1 minus alpha. And the event of receiving first bit correctly and second bit correctly, they are all independent of each other. So probability of receiving a block correctly means probability of receiving n bits correctly. Receiving a block correctly or n bits correctly, both are same, which means probability of receiving one particular bit correctly is 1 minus alpha, and second bit correctly is also into 1 minus alpha into 1 minus alpha, like that n times. So it means 1 minus alpha whole to the power of n. Now they are asking us to find the probability that the received block is erroneous. So probability of receiving a block erroneously is equal to 1 minus probability of receiving correctly, which is 1 minus of 1 minus alpha whole to the power of n. Right, so that's the answer. Right, so let us do this question. So they have given a question on PM modulation, and they have given a question on PM modulation and FM modulation. Right, so we know instantaneous frequency, they're talking about instantaneous frequency here. If the highest instantaneous frequency of PM and FM are same, then the value of ratio of Kp by Kf, this is what is the question. This is the message signal given, and if you observe, the message signal peak amplitude is 10, and if you observe what is the slope here, slope here is in this region is 5 units, and in this region what is the slope? Slope in this region is, in 1 unit it has decreased by 10 units, so slope is minus 10, and in this region slope is 0. Right, so these slopes will help us to find the answer. So instantaneous frequency for any signal, not only for PM signal or FM signal, it is given as 1 by 2 pi d by dt of theta of t. Theta of t means the angle of the signal. So let us find for PM signal, Fi PM signal is equal to 1 by 2 pi into d by dt of 10,000 pi t plus kp into m of t, which is equal to 500 plus kp divided by 2 pi into d by dt of m of t. Similarly, Fi Fm signal is equal to 1 by 2 pi into d by dt of 10,000 pi t plus kf integration from minus infinity to t m of tau d tau. So this is equal to 500 plus kf divided by 2 pi into m of t, because differentiation and integration you can think of it as they'll get nullified, so what remains is m of t. So instantaneous frequency of PM, the maximum value, is same as instantaneous frequency of FM maximum value. So which is 500 plus, what is the maximum value of PM instantaneous frequency. Instantaneous frequency of Pm is maximum when d by dt of m of t is maximum. Modulus of d by dt of m of t is maximum. Whenever modulus of the magnitude of d by dt of m of t is maximum, if the highest instantaneous frequency, right? Yeah. If the highest instantaneous frequency, yeah, they're saying highest, okay? They're not talking about deviation. So we had to be a little bit careful here. Yeah. So d by dt of maximum is equal to 500 plus kf divided by 2 pi into m of t maximum. When m of t is maximum, instantaneous frequency of fm is maximum. When d by dt of m of t is maximum, maximum positive value, because they are asking about highest frequency, right? So in that case, so when d by dt of m of t is maximum, we get maximum instantaneous frequency for Pm. And when we get m of t maximum value, we get maximum instantaneous frequency in Fm. So this is equal to 500 plus, this looks straightforward, kf divided by 2 pi into what is the maximum value of m of t? It is 10 units. Okay. So here we can cancel this 500, right? So in the other case, it is kp divided by 2 pi into what is the maximum value of d by dt of m of t? Maximum slope here is 5, here it is 0, it is minus 10. What is the maximum slope possible here? It is plus 5. And here it is minus 10. Magnitude of this part is minus 10, but when d by dt of m of t is minus 10, instantaneous frequency is 500 minus kp by 2 pi into 10. Which means this is when d by dt of m of t is minus 10, we are not getting maximum instantaneous frequency. We are getting least instantaneous frequency. Okay, so that's why it's not modulus, because they are talking about highest instantaneous frequency. So the value is 5 units. So 2 pi cancelled. They are asking us to find kp by kf, which is equal to 2 units. Okay, so the answer is 2. So let us answer the next one. Okay, so x of t is given as x of t is given as m of t into cos 2 pi fc into t. Okay, and m of t is given as 4 cos 1000 pi t into cos 2 pi fct. Okay, and yeah, so now at the output of multiplier, what we have is x of t multiplied with cos 2 pi fc plus 40 into t. So these two are multiplied, this signal and this signal are multiplied, and after that it is being passed through a low pass filter. Low pass filter with cutoff, you can draw a line here. This is 0 line. It is allowing, this low pass filter is allowing frequencies from minus 510 to plus 510, which means upper free cutoff frequency is 510 hertz. Right, let us understand the output here. So this output is equal to 4 cos 1000 pi t into cos 2 pi fc into t into cos 2 pi fc plus 40 into t, which is half into, because you can look at it as cos a into cos b. We can, since 2 is not there, I'm dividing with 2 and multiplying with 2. Now it becomes 2 cos a cos b. You can write it as cos of a plus b, cos of 2 pi into 2 fc plus 40 plus cos of a minus b, cos 2 pi 40 into t. 2 and 2 cancel, becomes 2. Now it is 2 cos a cos b again. So 2 cos terms multiplied. So we can expand it as cos of, let us write this as 2 pi into 500, 2 pi into 2 fc plus 40 plus 500 is 540 into t plus cos of a minus b will be cos of 2 pi into 2 fc plus 40 minus 500 is minus 460 into t plus So cos A into cos B. These two terms multiplied, what happens? 2 cos A cos B, cos of A plus B. Look at this as cos 2 pi 500, cos 2 pi 500 into cos 2 pi 40 into t. So it is cos of 2 pi into 540 into t. This is cos of A plus B, plus cos of A minus B is cos 2 pi 460 into t. Right, observe this one. Since FC is 1 megahertz, so this frequency is very huge. 2 times 2 megahertz plus 540 hertz, it will not be allowed by this filter. This part will not be allowed by this filter. This part, 2 megahertz minus 460, this also will not be allowed by the filter. This part, the frequency is 540 hertz, that also will not be allowed by the filter. Only this part will be allowed. So the answer is cos 2 pi 460 into t, which means cos 460 into 2 is 920. So option 3, cos 920 pi into t. Fine. So that's the answer. Okay. One more question we need to solve. The last question. And this is the most crucial question actually. So this question can be solved in a commonsensical way also, or we can go in depth and detail and discuss also. So let me discuss the commonsensical way of understanding it. So if you observe, the first symbol is -3, second symbol is -1, third symbol is +1, fourth symbol is 2 units. Now these symbols are added with noise. So when you add noise, what happens is, because of noise, when you send -3, you may not receive it as -3, you may receive it as something else also. Or you may receive it as -3 or -3, 2.9, -2.8 like that, and you may receive something more than -2 also. -2 is the midway. The midpoint of -1 and +1 is 0. And midpoint of 1 and 2 is 0.5. Okay. So noise can be positive or negative. They are giving that 0 mean unit variance Gaussian random variable. So when you send -3, only when the noise is positive and when it is greater than one value, only when the noise is more than 1 unit. So only when the noise is more than 1 unit, then only when you transmit this symbol, it will go beyond -2, right? So only in that case we get an error. So whenever P of W, whenever noise is greater than 1, only then we get error when you transmit -3. And here, when you transmit -1, if noise is greater than 1, then you get an error, because when noise is greater than 1, you will receive something more than 0, which means you will understand it as this symbol, S3. This is S1, S2, S3, S4. Because of noise, if you receive any voltage in this range below -2, you will understand it as, okay, this is -3 or S1. If you receive a voltage between -2 and 0, then you will understand it as S2 symbol or -1. When you receive a voltage at the receiver between 0 and 1.5, 0 and 1.5, you will understand it as S3. And if you receive a voltage greater than 1.5, you will understand it as S4. So that is how the threshold criteria will be, or map criteria or ML criteria you can say. Right. So if you observe, if noise is greater than 1, then the received voltage crosses 0. Though you have transmitted -1, because of noise it will cross 0. And when your noise goes below -1 also, then also it crosses this line, threshold line, and you at the receiver we might understand it as -3 because it crosses this line. So in both cases we get error. And in this case, if the noise goes more than 0.5, if the noise is more than 0.5, it crosses this line. And if the noise is less than -1 also, then also we get an error. And in this case, when you transmit 2, if the noise is less than, if the noise is negative and less than -0.5, when 2 gets added with any value less than -0.5, then only we get an error, because received voltage is in this region. So if you observe all this, so probability of error in this is smaller only, because the contribution is due to P of W greater than 1 only. But here it is due to W greater than 1 and W less than -1. And here it is due to probability of W less than -1 and greater than 0.5. Which one will be the highest? You know what is Gaussian curve? Okay, so W greater than 1 means this area. W less than 1 means this area. Less than -1 means this area. This represents P of W less than minus 1, and this represents P of W greater than 1. And what is P of W greater than 0.5? W greater than 0.5 means it will be this area. All this area is nothing but P of W greater than 0.5. Right, tell me this, P of W greater than 0.5 and P of W less than minus 1, this area plus this area will be the highest area. So among all these probability of errors, this will be the highest. This will be the highest. So that's why when you transmit a symbol with index 3, when you transmit S3, probability of error is highest. Probability of error is highest. So this is the most commonsensical way of answering it. Since I'm explaining, I have taken this much time. If you have understood what I'm talking about and if you have analyzed in that manner, it is hardly a half-minute question. It is more of commonsensical question, right? Next, so let us discuss this in another manner. So how can we discuss this in another manner? So they are giving y is equal to s plus w, and we know about w. So w has a zero mean and unit variance. So w PDF is going to look like this, something like this, as a function of w. This is how fw of w looks like. And y given s1, if you transmit s1, and then what is the value of y? It is s1 is equal to s1, s2, s3, s4. These are the four symbols that we are transmitting, and the values are minus 3, minus 1, 1 and 2. These are the values transmitted. So what will be the received value? S value will be minus 3 plus w. Similarly, y given s2, if you transmit s2, the received value will be minus 1 plus noise. If s3 is transmitted, then received value will be 1 plus w. Y given s4 is equal to 2 plus w. And if you observe, expectation of y given s1 is equal to, expectation is how much? Minus expectation of minus 3 plus expectation of w is 0 because mean of noise is 0. Similarly, expectation of y given s2 is equal to minus 1. Expectation of y given s3 is equal to 1. Expectation of y given s4 is equal to 2. Now observe this one, y equal to s plus w. If w is Gaussian and s is like some constant, if w is Gaussian, y also should be Gaussian, correct? So y also should be Gaussian. Y also should be Gaussian, and given s1, yes, it is Gaussian with mean minus 3, and what is the variance? Sigma y square. If you add some constant to a random variable, if you add some constant, what happens is DC power changes, AC power does not change. So adding a constant will not change the variance. So in all these cases, you are adding with some constant. So because of addition of constants, variance of y will not change. Variance of y is same as variance of w because s has different constants. So minus 3, minus 1, 1 and 2, they add to different, they add to DC powers but not AC power. So that's why in a common sense way we can say that variance of y given s1 or s2 or s3 or s4, it is same, and which is same as variance of w square. And what is the variance of w? They have given it as 1. In the question they have given that it is unit zero mean unit variance noise random variable, right? So this is the given data. Now you can plot the PDF. If you have listened to my class on map criteria, ML criteria, and probability of error derivation, so you'll understand much better and you would have solved it very easily. Anyway, so let me discuss this here. So what is the PDF? The probability of received signal y given S1. It is also Gaussian because W is Gaussian, y also will be Gaussian given S1. The mean value is minus 3. So let me plot the PDF here. Next, minus 1. So this is the PDF of y received random variable when S1 is transmitted. Similarly, what is the PDF of the random variable when S2 is transmitted? When S2 is transmitted, the mean value is minus 1. For Gaussian, since W is Gaussian, y also will be Gaussian with mean minus 1. So I'm plotting here P of y given S2. So that also will be Gaussian. Next, P of y given S3. When 1 is transmitted, y is equal to 1 plus w when S3 is transmitted. Since w is Gaussian, y also will be Gaussian, but with mean value 1 and variance same as 1. So if you plot it, next, P of y given S4. So the P of y given S4 is also Gaussian with mean 2 units. Right. Now let us talk about probability of error. So whatever is the meeting point of the PDFs, that will be the threshold voltage. In this case it will be -2, and in this case it is 0, and in this case it will be 1.5. Since they are saying ML decoding, maximum likelihood decoding, you can assume that probabilities of all the symbols are equal. So if the probabilities of the symbols are equal, then it will be just the midpoint of the mean values. Midpoint of mean values will be the threshold voltage. The meaning of this is, if y is less than -2, decision, what is the decision? Whenever you receive voltage less than -2, according to ML criteria, what is ML decision? According to maximum likelihood criteria, decision is, understand it as yes, 1. Whenever you receive voltage less than -2, you understand that you make a decision at the receiver that S1 is transmitted. If y is between y is between -2 less than y less than 0, then according to ML decision, you are going to decide it as yes2. Similarly, if 0 less than y less than 1.5, then according to ML decision, it is S3. Right. Similarly, if y greater than 1.5, what is ML decision? If y greater than 1.5, you are going to make a decision as S4. Okay, right. So if you receive a voltage, if you transmit -3, and if you because of when you transmit -3, there is a chance of receiving the voltages greater than -2, and with this probability you are going to receive voltages greater than -2. So when you receive these voltages, when you transmit -3 and receive these voltages with this probability, what happens is, whenever you receive a voltage greater than -2, you're going to make a decision as S2, but what you have transmitted is -3 with this probability. So this will be the probability of error given S1. Next, similarly, given S2, if you receive a voltage in this range, you're going to make a decision as S2, and that is correct. But when you transmit S2, there is a chance of receiving voltages like this. There is a probability of receiving voltages outside the range -2 to 0. Correct? Outside the range -2 to 0 with this probability. With this probability and with this probability, we can receive voltages outside this range. Which means with this probability, we're gonna receive. This is the probability of error. This probability, this area plus this area will give you probability of error given S2. Similarly, when S3 is transmitted, when S3 is transmitted, so this is the probability of error, and this also will be the probability of error. So this area and this area total combined, we get probability of error given S3. Similarly, when S4 is transmitted or 2 is transmitted, if you receive a voltage, if you receive any voltage less than 0.5, I'm putting with dots, this is the area with which we get an error. So among all the areas, if you observe, this is the only area for probability of error given S1, and this area plus this area will give you probability of error given S2, and this big area and this area will give you probability of error given S3. Probability of error given S4 is only this area. So if you compare all the probability of error areas, probability of error given S3 is highest. So what they have asked is, when do you get the highest error? When S3 is transmitted, we get the highest error. Probability of error is highest if S3 is transmitted. Okay, so that's it, guys. So we have discussed all the communication system questions, all the questions on communication systems, and let me wind this up. So it's not a very difficult paper, and as well as it is not an easy paper as well. So before winding up, let me tell you a few things. Yeah, so I'm running a course, so you can go through my profile for the courses that I'm doing on Unacademy Plus. So right now I'm taking a course on analog communication. So this is a paid course, you cannot watch it freely, you have to take the subscription. To watch all these videos. So, and one more thing is I'm taking a course on Excel Gate also. Along with me, Suresh sir, Trinath sir, and B.V. Reddy sir. So we 4 people are going to teach all the subjects of electronics and communications. So extraordinary faculty. So if you want to take subscription, you can contact me on my Telegram ID. You can contact me on my Telegram ID. It is Dinesh. Give me a second. This is my Telegram ID, this is my name, and that itself is the Telegram ID. You can ping me on this Telegram ID if you are interested to take subscription. So there is my referral code for Unacademy. My referral code for taking subscription is my name itself. If you want to take subscription on Unacademy Plus, you can use my referral code while paying the fees. You can use this code for 10% discount. Right, so come join us if you want to learn well, and if you are serious about cracking the exam, you can come and join us. We'll be happy to teach you. So you can follow us on our Unacademy page, so that you'll get all the updates on our classes, our free classes, as well as the regular courses. Right, that's it, guys, from my side. Thank you so much for listening to me. So if there are any doubts, you can post it in the comments. I'll try to answer it. Thank you.